Good afternoon, Accelerated. It is April 17th, 2:34 p.m. This is the day after you have the five problem quiz. So the problems that I have on here are all from the five problem quiz. Hey, look, man, this virtual learning, it sucks. Believe me, I'd rather be in front of your faces, man, cracking jokes, being around all of you guys, but it's not going to happen. So with that, if you know there are things you're struggling with in any of your classes, this is a great time to really work on advocating for yourself. I think Ari just hit me up yesterday. Hey, Mr. Lake, I'm kind of lost. I'm kind of stuck on some things. Great. Iverson's been hitting me up here and there, and I appreciate that. But you guys are going to have to be a little bit more specific on what you need help with. I know I provide a decent amount of resources, so it's tough just to say, or for me to know that you just have access to nothing. Like I've provided nothing to be able to help you out. Go back on my blog to beginning of April. I think it was like March 30th was like the beginning of this unit that I put in there for April. I have the PowerPoint, I have the Vertex form handout. Like there's several things that are there, and I have videos that I've attached on every day. So me being in front of you in class is almost like watching the videos that I've made for you too. No, you can't ask live in person questions, but the resources are there. And then boom, hit me up later. If you want me to do a Zoom tutoring, let me know and I will do that. That's not a problem. But none of you are letting me know what you need. So I'm not going to spend my time doing all this extra stuff that some of you might not even use. Any one of you want a personal one-on-one live Zoom tutoring, let's make it happen. That's not an issue for me. But if you aren't speaking up for what you need, I can't meet you at your needs. So then now you're kind of lost. The grades for this section will count. So if you end up, failing the course because it just hasn't been working out and you aren't getting the material, a lot of that weight's going to be on your shoulders, not as much on mine. So let me know how I can assist you and get you where you need to go and to get this material down. Okay, enough of that. Well, this the first problem that I have on here. Sketch a graph with the following equation, right? F of x equals negative times the sum of x plus 4 squared plus 4. So right away, what I want to do is I want to talk about a, right? So a is a leading coefficient. So if I go with the equation of, I have it in green, that's fine. Y equals a times x minus h squared plus k, right? That is the vertex form of an equation. We have our a. Now our a, actually, I might even skip down to another part of the question down here, because if I answer a up here, then I'm going to answer it. Well, I'll leave it up here, then go down and answer it later. So a is going to tell us two different things. One, A is going to inform us of concavity, right? Now, concavity is the way that your graph is going to face. Is it going to be upwards facing or downwards facing, right? So if the graph is shaped like this, it's going to be concave up. This means that A has to be positive if it's concave up. Conversely, it's going to tell us if it's going to be concave down. So if our graph is shaped like this, it's going to be concave down. That means that A has to be negative. So this is when A is negative, this is when A is positive. So that's the leading coefficient of your equation, right? So no matter what the number is, we're talking about just the value. If the value is positive, you're concave up. If the value is negative, it's concave down. So that already tells you which way your graph is going to be facing. Now, the second part of that is if you're going to have a vertical stretch versus a vertical shrink. So we have a vertical stretch, right? Let's just say as an example. A vertical stretch means that you're going to have a pretty skinny graph. It's kind of stretching as it gets further and further up or further and further down based upon if it's concave up or concave down. So vertical stretch means that your A, and we'll put it like this. We'll say that the A is going to be greater than or equal to 1, or A is less than or equal to -1. So as long as your A is greater than or equal to 1, it's a stretch. Or if it's less than or equal to -1, it's going to be a stretch. So that means you're just going to have kind of like a skinnier graph because your Y values are going to be growing faster and faster the further your x's are, right? So the further your x's are, if your x is at 5, 6, and 7, your y's are going to be growing much, much faster, much further up. So that means that your graph is going to be stretching because your leading coefficient, your a, is either greater than 1 or it's going to be less than -1. So then you have a vertical shrink, which means that now your a is for the most part a fraction in between -1 and 1. Now, I've said fraction before, a couple classes I've said this like prior to this year, and let's say you have a 2.5. Oh, that's automatically a shrink. It's a fraction. No, that's a mixed number, right? But 2.5 is greater than 1. So that means it has to be a vertical shrink, a vertical stretch for that example. But in this case, though, you're going to have your a is going to be in between -1 and 1. I'm sorry about that. Let me go back because I cannot have two equal twos here. There we go. So this is going to be your vertical shrink. If your A is in between -1 and 1, right? We're talking about a 0.5, 0.8, a half, a third, 3/5, any of those type of leading coefficients, you're going to have a vertical shrink because that means that now your y values are going to be. I'm gonna give some more examples of these and which we're going to have, but that means that now your y values are kind of truncating or kind of shrinking down. You're not rising as fast. You're rising at a much slower rate. Because now, let's say you're taking half of all of your values that you plug in for x. Now you're taking half of those values. So now your graph is going to be much wider graph because your y values are going to be much smaller than they would be if it was a whole number. So your vertical stretch, whenever your leading coefficient is going to be greater or equal to 1 or less and equal to -1. And you have vertical shrink if your leading coefficient is in between -1 and 1, right? So that just kind of gives you if your graph is going to be wide, if it's going to be narrow, if it's concave up, concave down. So A gives you really two very important factors of information that for each individual graph. So we already know that we're going to have a concave down graph because we see that our leading coefficient here is going to be negative. So we know it's concave down. And then we have now with this being the equation, we know that our H and K is our vertex. That's why I like this form. It's vertex form because it already gives you really key information as soon as you look at it. Standard form is not as clear. We're going to get into that. But vertex form tells you right away some things as soon as you look at the graph, as soon as you look at the equation. Vertex is H and K, right? So we know that here with the equation that this right here means that it's going to be the opposite sign. This right here is going to give you the opposite value here, opposite sign. So whatever you have inside the equation is going to be the opposite when you take it out for the vertex, right? So that says that we have a +4, well, it's going to be the opposite. So that means that our vertex is going to be -4 and 4. So we know that we have a concave down graph with a vertex at -4 and 4. So we have a vertex at -4 and 4. We know it's going to be concave down, but let's give ourselves just, a couple of points that we could possibly use. So I'm going to do this here. On the side over here, we have a small, not a small, but I'll make a 3-column table here. We have our x. We're going to have our function in the middle. We have our y over here. Let me do it like this. X, and then I'm going to use my f of x because that's what y is, f of x. The function at the point of x. So let's say I'm going to make x. Now, I have also perfect. What I can do here, I know that if I have my h value of my vertex, that also gives me my axis of symmetry, right? Because for AOS, my x equals h. So whatever this value is, that also is going to be my value for my axis of symmetry, right? That point, and it makes sense, right? If this line is going to split our graph in half, it's going to cut right through our vertex because our vertex is, quote unquote, that turning point of our graph. So the AOS should split our vertex right in half. So the vertex has to be on that line. So in this case, our vertex is negative 4, 4. So our AOS is x equals negative 4. And that's going to be very important. I'm going to tell you why we really have to know what that is. It makes it easier to graph our equation. So I'm going to draw this vertex right through here, and I'm going to label it, right? I'm going to put x equals negative 4. I'm going to label that one. My vertex point, I'm going to put negative 4 and 4. I want to label everything I have on here that are key components. So now that I have those two pieces, right, I want to use my AOS as a way to help me graph or find other points of this parabola here. So I'm going to go ahead and plug in negative 3, right? That's on one side of my AOS. I'm going to plug in negative 3. If I work this out, where's my equation? Okay, there it is. So now let's see, let's do it this way. I'm gonna just do the work up here, have a little more space. So I have f at negative 3 equals negative 3 plus 4 squared plus 4. So f at negative 3 equals the opposite of negative 3 plus 4 is a 1 squared plus 4. F at negative 3 equals, let me see, 1 squared is 1, but 1 times negative 1 is a negative 1 plus 4. So I'm going to continue over here. F at negative 3 equals 3. All right, so my ordered pair for that one is 3 and 3. So this becomes 3, and then my ordered pair is negative 3 and 3. All right, so let's go ahead and plot that point, right? So we have negative 3 and 3. But down below, right? I think it might be, which question was that? This is something I was trying to get to. Okay, right here for question 5, right? See if you can use the AOS as a line of reflection. Find 2 points on one side of the AOS, then reflect them over that line of reflection, right? Because we're using those two words interchangeably. So I'm going to use this AOS as a line of reflection, right? So we know that whenever I'm going to reflect a point, it has to be equal distance on both sides. So if that's my line of reflection, this is 1 unit away right here from the line of reflection, or AOS. I'm going to go 1 unit over here, right? Because my points have to be equal distance, the same distance from each other. So now, when I found negative 3, 3, I've automatically found negative 5, 3. That point's automatically there once I reflect that point. So I hope some of you were seeing, that's what I was trying to get to. I didn't say it directly, but that's what I wanted to get to. So now we're using this AOS as a line of reflection because they kind of mean sort of the same thing. Excuse me. So now I want to find one more point. Usually want to have 5 points to make this really kind of like a real seamless and attractive graph. So I'm going to do one more point. I already used negative 3. Now let's use negative 2. So now I'm going to go f at negative 2. So now f at negative 2 equals negative 2 plus 4 squared plus 4. F at negative 2 equals negative 2 squared plus 4. Let's go. F at negative 2 equals, that's 2 squared is 4, but 4 times negative 1 is that negative there. There's negative 4 plus 4. So we have f at negative 2 equals 0. So my ordered pair is negative 2, 0. So I'll put over here, when I plugged in negative 2, I'll have 0. So my ordered pair is 2, negative 2, 0. So now for that point, at negative 2, let me go back to green. Negative 2, we have 0, and that's my ordered pair right there. So then now, remember now, or my point, we're going to go ahead and make sure that we're using this AOS as a line of reflection. So I'm moving 2 points, 2 units, 1, 2 to my line of reflection, or my AOS. I'm going to use 1, 2, 2 units the other direction now. So when I found the point at negative 2, 0, I've also found negative 6, 0. Now, this is my quadratic. I can just keep it right here. This is my quadratic equation now. A little bit smoother. You want to have 5 points. That's what that problem should be. So this is what your answer should look like. I think you might have skipped around the numbers. So if number 1 for me could have been number 3 for you. It doesn't really matter. But for this problem, this is what your graph should look like. So if you didn't get this, I suggest you go back, look at it, and regraph this on a separate sheet of paper. I think that's what's happening. I'm kind of giving material out and giving answers to other problems that have been assigned, but I think a lot of you are going back and redoing those problems. You really should. So this is question 1. Now, I've answered a couple of questions in this problem already. So I know I already answered. Oh, number 2. Number 2 is already answered now, right? What is the name of the line that splits your shape in half and causes points to be equidistant from each other on either side of the line? There are 2 possible answers. The term we are using, this unit. This unit, we're talking about this line right here, the axis of symmetry, right? So we know right now this unit is called the AOS, or the axis of symmetry. Okay, and now the one that we used last unit, I just brought it up just now. I think it's looking at question 5, right? And I used acronyms on purpose. I don't want to give you the answer. It's that LOR. And that LOR stands for line of reflection. So last unit we're looking at reflections and translations. We talked about line of reflection. So I'm trying to, have you make connections to each unit so you can see how some of these terms apply. Line of reflection.